Hello students, in this video I'm going to go through an example, or actually three examples, of what we can do to divide polynomials using an alternative method from long division. And the method is called synthetic division. So let's take a look. So what I want to do is I want to evaluate f of x over g of x. And f of x over g of x is this polynomial, this fourth degree polynomial, divided by this binomial. So what I want to do is I want to perform this division, and what we would have normally done using long division is we would have then said, oh, this is the same thing as x minus 2 divided into this big expression here. So this method I want to show you now, okay, is called synthetic division because it's not real division. I mean, when you hear the word synthetic, it's fake, right? So so it's an alternative, okay? Whenever you have a division problem where you're dividing some polynomial by some binomial, by some linear binomial, let me just reemphasize that, by some linear binomial, then this method can be useful, okay? So what we do is we're only going to extract only the important pieces of information here. And notice in this problem here, I forgot to do something really important, and that is we had to put in a placeholder for the x squared term here, so plus 0x squared, right? So when we perform synthetic division, okay, we have to do something very similar. So how does synthetic division work? So what you do, okay, we're going to write out, okay, the divisor over here. This is x minus 2, but I'm only going to take the important piece of information there, which is the number 2. And I'm going to place this inside of a box like that, and I'm going to list out all the coefficients in for every single term, okay, that I have. So I have 1, 0, negative 20, and 32. And what I want to do with this, okay, is I want to perform synthetic division, and the algorithm goes like this. Okay, so the 1 comes down, and what we want to do, okay, is we're going to take 2 times 1. So again, we're going to take 2 times 1, and that gets me 2. And then we're going to add, okay? I place 2 over here. And then we're going to add, and that gets me 3. And then we're going to, again, take 2 times 3, which is, we're doing this. And then we're going to place it there, okay? 2 times 3, and that gets me 6. And again, we're going to add, and that gets me 6. 2 times 6, that's 12, and we're going to place it over here, and that gets me 12. And I'm going to add, so it gets me negative 8. 2 times negative 8, that gets me negative 16. And again, I'm going to add, and when I add, I get positive 16. And this number right here, okay, is actually our remainder. And how do we interpret this? This is going to be x to the third plus 3x squared plus 6x minus 8 plus remainder of 16, so it's plus 16 over x minus 2. Let's just confirm whether or not, what we did here actually is consistent with what we would have gotten with long division. So I want to move this and place it over here. And again, I'm going to go through the same problem using long division so you can see, compare and contrast. So what I do is I take x minus 2, and what am I going to do with that? I am going to multiply that by x to the third. So I'm going to write x to the third. So I have x to the fourth minus 2x to the third, and I'm going to subtract. And when I do, notice what happens. Minus negative, that becomes addition. So that becomes 3x to the third. Hence, that's why we add, right? And I'm going to do it again. I'm going to pull down the 0. So plus 0x squared. And again, I'm going to multiply by x squared, or 3x squared. So I get 3x cubed minus 2x squared. And again, I'm going to subtract. And I get 2x squared. And I pull down to negative 20x. So what am I going to do? I'm going to multiply by positive 2x. So I got 2x squared. I'm sorry, I made a mistake here. That's why I looked over there. So 3 times 2 gets me 6. That should be 6x squared. And then from there, this should be not 6. This should be 6x squared minus 20x. And here should be 6x. Right? So now I get 6x squared minus 12x. And I subtract. So I get negative 8x plus 32. And I'm going to subtract by 8. So I get negative 8x plus 16 minus 16. And subtract. Right? Negative 8 times negative 2 is positive 16. And now I subtract, and if I do, I get positive 16 as my remainder. And that was exactly what had happened. Let's compare and contrast what happened here, right? So all the coefficients here, it was 1, 3, 6, negative 8. Right? That's exactly what I have. 1, 3, 6, negative 8. So whenever you are performing synthetic division, okay, one more time, okay, we're adding the numbers. Let's try another example. I have x plus 2 here. Let's try f of x over h of x. So we're going to figure that out. F of x divided by h of x. So again, this time, h of x is x plus 2. So it's essentially the same problem. The difference here is, instead of dividing by x minus 2, I'm dividing by x plus 2. So how will that work? Well, the divisor here, the x plus 2, okay, what I do is I'm going to extract that information there. So instead of writing plus 2, I'm going to write negative 2, okay? And I am going to take all the coefficients one more time. So it's 1, 1, 0, negative 20, and 32. And again, I'm going to perform a synthetic division. I pull down the 1. This comes down. So it's 1. 1 times negative 2 is negative 2. 1 plus negative 2 is negative 1. Negative 2 times negative 1 is positive 2. 0 plus 2 is 2. Negative 2 times 2 is negative 4. Negative 20 plus negative 4 is negative 24. Negative 2 times negative 24 is positive 48. And that will get me positive 80. So what is the result then? This is the same thing as x to the third minus x squared plus 2x minus 24 plus 80 over x plus 2. All right. Let's try one more time. Now I have j of x is 2x plus 4. All right. So j of x is 2x plus 4, so I have f of x over j of x. And the problem here it becomes 2x plus 4. We run into a problem. Synthetic division only works when the leading coefficient of the divisor is 1. So what does that mean? Well, what that means is, okay, we are going to need to manipulate this, right? This 2 times x plus 4, we will have to, again, factor out a 2 to get x plus 2. And the numerator there stays the same. So what ends up happening is, okay, this is the same thing as 1/2 times this thing. Whoops. So let me get rid of that too. It's equal to 1/2 times that. So in order for you to perform the synthetic division, okay, again, the divisor, meaning the expression on the denominator there, okay, it always has to be linear. The leading coefficient always has to be 1. We have to manipulate this. So in order for us to perform this division then, this is equivalent to, again, 1/2 times the answer that I got before. And we've already performed this division, didn't we? This guy here, didn't we perform that division just a moment ago? Right? Wasn't that completed in this step over here? We did that already before, right? So in order for us to figure this out, this is the same thing as, and we figured it out over here, by the way, right? In case you guys forgot. So this is the same thing as x to the third, x to the third minus x squared plus 2x minus 24 plus 80 over x plus 2. That's what it's equivalent to. All right, so let's just summarize what just happened here, right? So f of x divided by, let's say, g of x, we can perform synthetic division. So synthetic division may be performed if g of x is either x plus a or x minus a. So in the event of x plus a, okay, what we do is this becomes negative a, and then you write the numbers. In the case of x minus a, you're going to write in positive a over here, and you write in the numbers and you perform the synthetic division. Whenever you perform the synthetic division, okay, we're always adding. We are always adding. The last number that you get, this is our remainder. And then all of these numbers over here end up being the coefficients. Okay.